How can we obtain the different gases from air? Air is a mixture of different gases. The main component in air is nitrogen. It's about 78%, and the boiling point of nitrogen is minus 196 degrees Celsius. The next major component is oxygen, which is around 20%, and the oxygen gas, liquid oxygen gas, boils at about minus 183 degrees Celsius. And then we have other components. Here we'll just focus on argon. Argon's boiling point of liquid argon is minus 186 degrees Celsius. So the different components of air are separated by fractional distillation. Why fractional distillation? You have seen the difference in boiling point is very less than 25 K. This is minus 186, minus 183. There's a difference of just 3 degrees. So since the difference in melting point, a boiling point, is less than 25 K, fractional distillation is used. In order to carry on the fractional distillation of air, it first has to be in liquid form. So this full air, we got to turn it into a liquid. We need to have liquid air, liquefy air. So here is a mixture of air. Now this air is now compressed, so you have pistons on both the sides that slowly compress the air. They push the air on either side and they compress it. Now here this air is compressed in a very small area, and hence it gets liquefied. The air is also cooled. It is cooled and compressed. Cooled plus compressed. The molecules get closer and you get liquid air. Once we obtain the liquid air then undergoes fractional distillation to give into different components. So let's just look up here what's given in your textbook. So we have air here. The air is then compressed and cooled by increasing the pressure and decreasing the temperature to get liquid air. Increasing the pressure and decreasing the temperature to get liquid air. Once the liquid air is obtained, it's allowed to warm up slowly in the fractionating column and get separated at different heights. Here's another summary of fractional distillation of air. So we first start with liquid air. And how do we get liquid air? When air is cooled and compressed. So after air is cooled and compressed, it turns into a liquid. Then from here they remove carbon dioxide and water vapor, because these form particles. Water vapor forms ice and carbon dioxide also forms dry ice. So these are removed, and then it enters into a fractional distillation. When it undergoes fractional distillation, it gets separated into nitrogen, argon and oxygen, because they have different boiling points. Now there's another point I want to make here is, look at the oxygen has minus 183 boiling point, argon minus 186, nitrogen minus 196. So if this is 0 degrees Celsius, then would come minus 183 would come here. Here would come minus 186, and here would come minus 196. This is of 183 is oxygen. This is the boiling point of argon, liquid argon and liquid nitrogen. Now when we are cooling the air is now going to get, the temperature is going to decrease. So it's going to come to 0 degrees, then it's going to come here. So oxygen will be liquefied first. When it comes to the order of liquefaction, as you move down, first oxygen becomes liquid, then argon becomes liquid, and then last it's nitrogen that becomes liquid. So order of liquefaction, it will be oxygen, then argon, and then nitrogen, in this order. Now let's see what happens for fractional distillation. When fractional distillation takes place, which gas is separated out first. So now fractional distillation, we move up here. Slowly the liquid air is heated. So first who will move out is nitrogen. Then as it moves up here, then will come argon. And as we move further, then will come oxygen. So this is the order in which the components will come out, emerge out of the fractionating column. Here is a spelling mistake, so that is nitrogen here. So I'll just put here nitrogen.